code. First thing we're doing is creating a symbolic function of type symfun, calling it x, and we're adding our variable, which is going to be t. So that's a variable that we're going to use to refer to it. Our mass variable here is declared. This right here is our damping variable, spring constant, all the way up to the line 11, stuff that we're familiar with. We're then going to create a y0 array, or it's a vector, it's a two-element vector using x0 and v0, which we declared right here. Here we're going to declare dx as the tth derivative of the function x here. So since x is symbolic, that's going to be symbolic as well. Equation 1 is then going to become the second derivative of equation x if it's equal to the stuff on the right. Right here, this is the relational operator, so it's not actually assigning anything. The vars array right here, it's created of function type t, or function x, which is going to be still the symbolic function, which is using the variable t. V, the ode to vector function, ode to vector field function, converts eq1, which is the same as the second order derivative, or the second derivative of function x. It's going to convert it into a system of first order differential equations as the vector v. MATLAB function converts the first order diff eq into a function type m. If it exists as a MATLAB function, this new function, then it's going to turn it into a doubles function instead of a symbols function, which is then going to make it a lot easier because we don't need to use the symbols toolbox. Vars right here is going to then put the variable orders as t and then capital Y here. Then we're just declaring interval here as another two-element vector going from t1 to t2. Ode 45, that integrates all of the function m, which is a first order differential equation now, from the intervals t1 to t2, setting y0 as the initial condition, and then it comes back as the structure vector sol. Sol then can be solved for at any point. You just have to plug it in. And this right here plots the first solution, that's what the 1 here is, of sol over the intervals from t1 to t2. And it only returns the solution listed in the vector interval, which is what's at here. So it's going to have t1 and t2, which are the endpoints here. So that's a little rough. Here we can see our graph, and like we said, it's going to go from 0 to 40, which are our